Try this question yourself. When you have done it, then watch the clip. Part 1. Y is equal to x cubed minus 3x squared plus 4. Then we get dy dx. 3 comes in the front. Reduce the power by 1. 3 times 2 is minus 6, so x. Now at stationary points, the gradient is equal to 0. So this is the equation of the gradient, and it's equal to 0. So we have 3x, the common factor, x minus 2 equal to 0. So 3x equal to 0 gives us a solution x equal to 0, or x minus 2 equal to 0, so we get x equal to 2. Then we substitute these values into the y function. So when x equal to 0, 0, 0 plus, so that get 4. When y is equal to 2, so x equal to 2, it will be 2 cubed minus 3 times 2 squared plus 4. So 8 minus 12 plus 4 is 0. So we get two coordinates, 0, 4 and 2, 0. Then second part, we differentiate the function again. So we get 6x minus 6. Then we substitute x equal to 0 into this function. We get 6 times 0 minus 6 is equal to minus 6. Because this is less than 0, so that means we're coming down after the turning point. So this implies maximum point. If we substitute x equal to 2, we get 6 times 2 minus 6 is 6. This time is greater than 0. That will be moving up after the turning point. That means we've been to the minimum point. So this confirms. So the first turning point is maximum, and the second turning point is minimum. We can also just sketch the graph. Because the turning point 1 is there, which is maximum, and this is another turning point is there, so we have graph going up, then to this local minimum point, then it goes up again. Right, for part 3, we have to find when this function is increasing. So we have the gradient dy dx is equal to 3x squared minus 6x. Now, function to be increasing, that means the gradient is positive. So we solve this inequality. So we have critical values, x equal to 0 or x equal to 2. Then we just sketch a little graph here. So that's 0, that's 2. Because x squared is a positive here, so it's a happy face. Now, because we want more than 0, so we shade the positive side of the curve or this way. So there are two solutions. The function is increasing, when x is less than 0 or x is greater than 2. But we could also see this from the original graph. The function here was going up, it was increasing up to that point. So that's when it was less than 0. And then obviously it was decreasing for that part, and then it's increasing again when x equal to 2 or more. Alternatively, this is your method. If you're finding the increasing function, you put the gradient more than 0. If you want to find the function when it's decreasing, you put the gradient less than 0.